Hi, it's Ms. Hochstetter to explain the PHET Wave Speed lab simulation and how we're going to do it. So this is the lab template, and I know it looks a little funny on here, but it's the same template we always use for lab: the question, the purpose, theory. So what we're going to be investigating for this lab is how an independent variable affects wave speed in a wave. So if you look back at lesson 6.07, that's kind of the pre-lab to this lab. So in that lesson, you already selected what your independent variable is going to be, for instance, to do this lab. So if you have not done that lesson, you definitely need to do it first before starting this, because it's just going to make everything a little bit easier for you. So the theory, mostly it's vocab. There's so much vocab in this unit. So you're going to want to make sure that you define those words, and then there's two equations there. And then this is the URL to click on the PHET simulation, and I'm going to show you how to set up this picture here that it shows. And then you're going to fill this stuff, so the independent, dependent, controlled variables, and hypothesis. So the good news is, if you did that lesson 6.07, you've already done these things, you just need to fill it in. And then you're going to make a plan, so that's writing down your procedure. This is your table. Whatever your independent variable is, you should do at least 5 of those. So like if your independent variable is amplitude, you're going to pick 5 different amplitudes to observe: the distance the wave pulse traveled, the time it traveled, and then of course calculating the wave speed. If you pick tension, there isn't numbers that go with the tension in the simulation, so you can just do low, normal, and high. So that's how you will do that. Then you're going to make a graph. The graph is very important for this one, because that's going to really tell you if your hypothesis is correct or not. And you should see a very clear trend no matter what you pick. And then, of course, the calculations, you will make it'll either be direct, indirect, or no relationship, or maybe some other type of graph. And then I want you to calculate the slope and explain what that might mean. Assumptions, limitations of errors, and then writing your conclusion. So what I'm going to do now is I am going to show you the PHET simulation. So here's the link. This is what it'll look like when you open it. You're going to push play, and it will open. And it's going to look like this, but this isn't how we're going to want to do our lab. The first thing, we're going to click on the top left-hand corner. We're going to switch it to pulse. And then on the top right corner, we are going to switch it to no end. And that just means that the pulse is going to go just through, and it's not going to like bounce back, whatever. It's just going to go like that. So I would recommend putting it in slow motion so that it's slower motion. And then if you use a ruler and a timer, the nice thing about the slow motion on the simulation is the timer will also go in slow motion. So you can measure the distance in centimeters of your wave. You can change the amplitude if that's your independent variable by changing this. And then, if you decided to do pulse width, you change it like this, and it'll show you that. If you're doing tension, you can do low tension, middle tension, and then high tension. Damping, that's basically the friction in the string. So there's always friction in a string. Like, some of the energy will be quote unquote lost or transferred into like heat in the string. If we were to do this in real life with real springs, which is what we would normally do if it wasn't for our current situation. But you can put it to none if you want. That's going to be an idealistic setting. Like, that won't necessarily happen in real life, but it'll be pretty close. Or, if you want to, you can mess with that. But damping shouldn't be your independent variable. That's just mostly relates to friction. Yeah, so then let's say that I pick amplitude. And then I would start my pulse, and I'd start the time, and I would time it for how long the pulse takes to get to the other end. And then there's my time, I use my distance, I calculate the velocity, and then I do that 5 times. Okay, so I hope this helps understand what you're asked to do for lab, and if you have any questions, of course, email me.